A thin cylinder of internal diameter 1.25 meters contains a fluid at an internal pressure 2 Newton per mm square. Determine maximum thickness of the cylinder if question number 1 the longitudinal stress if longitudinal stress is not to exceed 30 Newton per mm square. Second question, circumferential stress is not to exceed 45 Newton per mm square. Okay, so here he clearly mentioned it's a thin cylinder. Okay, now given cylinder is a thin cylinder, so he clearly mentioned. So first of all, let us list out given data. Okay, so first here he given internal diameter of cylinder, internal diameter of thin cylinder, internal diameter, internal diameter. So internal diameter di is equals to 1.25 meters. Okay, so let us convert meters into millimeters. We know that 1 meter is equal to 1000 millimeters. Okay, now internal diameter di is equals to 1.25 meters is equal to 1.25 into 1000 millimeters. 1 meter is equals to 1000 millimeters. Now 1.25 meters is equals to 1.25 into 1000 millimeters. So if you simplify 1.25 into 1000, how much? 1250 millimeters. Okay, so just whenever we are multiplying with the 10, 100, 1000, simply remove this decimal point and move then count number of zeros 1 2 3. Now move this decimal point to the 3 places 1 2 3, add 0. Okay, now next here is given internal pressure, internal fluid pressure, internal pressure P is equals to 2 Newton per mm square. Okay, now question number 1. So here we have to find thickness. Okay, now thickness of the cylinder, and first condition is if longitudinal stress sigma L, sigma suffix L is equals to 30 Newton per mm square, 30 Newton per mm square. So here longitudinal stress is 30 Newton per mm square. Now we have to find thickness of the cylinder if longitudinal stress is 30 Newton per mm square. Okay, okay, fine. So what is the formula for longitudinal stress in thin cylinders? Sigma L is equals to PD by 40. Sigma L is equals to PD by 40. Now substitute all values. Sigma L how much? 30 is equal to internal pressure 2 into diameter, internal diameter 1250 mm by 4 into T. What is T? Here T is thickness of the cylinder, maximum thickness of the cylinder, maximum thickness of the cylinder. Okay, next. So okay, we need maximum thickness of the cylinder. Let us simplify this 2 1s, 2 2s. Okay, now 30 is equals to 1250 by 2t. Okay, now transpose 2t, division becomes multiplication. So 2 into 30, 60t is equal to 1250. Now just transpose 60. Now t is equal to, multiplication becomes division. Now 1250 by 60. 0 0 get cancelled. Now 125 by 6. If you calculate its value, you will get around 6 2s are 2, sorry 12 and 5.0, so 20.8, so around you will get 20.84 approximately mm, 8333, but approximately 20.84 mm. So this is thickness of the thin cylinder when longitudinal stress is not to exceed 30 Newton per mm square. Okay, now this is first part answer. And coming to second part. So in second part, given maximum circumferential stress or hoop stress. Okay, now so circumferential stress, and what is the another name of circumferential stress? Hoop stress. So sigma c is equal to 45 Newton per mm square. Okay, now so based on circumferential stress, what is the thickness of the cylinder? So we know that circumferential stress sigma c is equals to pd by 2t. Now substitute all values. So sigma c is how much? 45 is equal to internal pressure. Internal pressure is 2 into internal diameter 1250 by 2 into t, 2t. Okay, so 2 get cancelled. Now transpose t, it will be 45 into t is equals to 1250. Okay, we need value of t, so now transpose 45, 1250 by 45. Okay, 5 9s are 45, 5 2s are 10, and 5 50s are, so t is equals to 250 by 9. If you simplify this, you will get final answer as approximately you will get 27.78 mm. Okay, therefore thickness of the cylinder based on circumferential stress is 27.78 mm. Okay, so to avoid failure we consider maximum of these two. So here we have two thicknesses, so 20.84 mm, 27.878 mm. Which one is larger value? Okay, now by taking larger value we can avoid failure of the thin cylinder. So maximum thickness would be maximum thickness. Therefore maximum thickness of the cylinder is 27.78 mm. Okay, now so to avoid failure we consider